Bismillahirrahmanirrahim. Good afternoon, everyone. Today, our lecture will be about the supernode technique, how we can solve the questions related with this topic, supernode technique. This lecture related with circuit analysis. Actually, I take three solving example from YouTube, but all of these were in Turkish language because that I translated it, and I was working to modify these solutions more by add another and more steps. All my targets about the lectures like that is I know many students want to complete our lecture, take big certificate, something like that, but they suffering like me because we study far away from our mother language, and at the same time I know many students study not by using English language. Many students in Turkey, in Russia, and many countries like that, and at the same time far away from our mother language, because that I use this language, English language, because like we know this, it's general language, because that I translated these three solving examples in this lecture by using English language, and adds many steps to simplify all of these solvents. Let's go directly to the details. Now we have this circuit with here the author writed it to us just V2, this node, because that I used another color here, and IS1 equal 3 ampere, IS2 14 ampere. Here we have three different amounts of resistance, 13 ohm, 4 ohm, 5 ohm, and here we have another independent voltage source, here to independent current source. Now let's go. When we facing situation like that, the first step will be to cancel the example like that. We will draw here line at the last line of the circuit, and we will say all of this line will be the reference line, or we can say reference points related with this last line of the circuit. Now, the author wanted from us calculate V1 and V2 from Kirchhoff current law. We will start by using this law. I1 here, I1 plus I2 plus IS1. You can say IS1 plus I1 plus I2 equal IS2. All of them, we can calculate all of them to make the results equal 0. And after that, by using Ohm law, I equal V divided on resistance, because that I1 equal V1 on 5 to V2 on 4, and IS1, like the author give it to us, equal 3 ampere, IS2 14 amperes, yes, here, 14 ampere. We will put all of these results here at equation number 1 to can write equation number 3 will be like that. And after that, we will simplify this equation number 3 more to be like that, 4V1 plus 5V2 equal 220 ampere. Now, V12, why I put it another node? The author give this point to us, or didn't, the author can give this circuit without draw or select the node with when will be, because that if the author just give it V2 to us, I must draw V1. Why? Because By this way, I will benefit from VS result, VS value, because we know V1, V2 equal VS. That means V1 minus V2 equal 10 volts. This will be another equation in this solving. Like I said before, V1 to equal Vs, that's mean 10 volt. Now let's try to calculate V2. Let's work at first equation, on equation 5. To calculate V1 and calculate V2, we will do some math trick. Will be like that. V1 minus V2 equal 10 volts. After that, minus 4 V1 plus 4 V2 equal minus 14V, like that. Now, equation 4 with equation 6, you can delete V1 and just calculate the V2 value. Will be like that. V2 equal 20 volts. We can put the V2 value at equation 5. You can calculate V1. Will be V1 minus 13 volts equal 10 volts. That's mean V1 equal 13 volts. Now let's go to the second equation at this lecture. We have circuit like that. We have 3 different amounts of resistance. The unit is kilo ohm, and here 2 milliampere that at this independent current source. That's mean different units, because that we can't say 2 exponential minus 6 kilo ampere or minus 3 ampere. Let's go deeply to the details. Here, with circuit like that, that's mean we in supernode technique, we must use it to come solve the unknown value. Here, VS, independent voltage source, independent current source, independent current source. We must put another node from left side, from here. Why? Because when I put another node number here, that's mean I can benefit from VS value, because V2, V1, or we can say V1, V2 equal VS equal 6 volts. This will be important equation to us. When we know the unknown, the first unknown, we can calculate the second unknown from this equation, or by using this equation. Here it will be V2 to can say V21 equal VS equal 6 volts, like I said before. After that, the resistance equal 12 kilo ohm will be here. At V2, the last line will be the reference, like I said before. All of the results here, all the voltage here, voltage drop here equals 0. For example, V1 reference divided on 3 kilo ohm equal I1. That's mean I1 equal V1 on 3 kilo ohm, and something like that. Let's go to solve this question. Now 6 volt equal V2 minus V1 from Kirchhoff current law, and from Ohm's law to V3. We'll start from V3. Yes, V3, V1, V2, V3. Yes, let me complete from here. Add from Ohm's law at V3, I32, let me show you, I32, this current, equal V3 minus V2 divided on 12 kilo ohm. That's right. plus I3A. I3A, let me see it, I3A here, from this point to this point, will be V3 divided on 6 kilo ohm, equal I3B, I3B, this. That's mean here, this current equal V3 equal 14 milliampere, will be IS1, we can say. Now, by using Ohm law, V3 divided on 6 minus 14 milliampere plus V3 minus V2 divided on 12 Kelvin ohm equals 0. Now let's work on the V2, V1 nodes. Like we see here, IS2 plus I1, IS2 plus I1, the current direction from here, IS2 plus I1 plus I23. I23 came from this side, because that we can say IS2 plus I1 equal minus I12, or like I write it here, plus equal minus I23. After that, put it in the side to make the equation equal 0, will be like that. From Ohm law will be 2 milliampere plus V1 on 3 plus V2 minus Vs on 12 kilo ohm equals 0. Now to calculate V1, we will work on equation 2. Equation 2 here, let me write it again. V3 on 6 kilo ohm plus V3 minus V2 on 12 kilo ohm minus 14 milliampere equals 0. Here an ampere will be exponential minus 3. Let's modify this equation more by dot 12 to can delete all of that to be simplified more, will be equal 3 V3 minus V2 equal 168. Equation 4. We'll depend on it. Now let's work on equation 3. Like that equals 0. Like I said, if we want make all the units at the same amount, will be kilo ohm exponential minus 6 dot 12 for V1 plus V2 minus V3 equal minus 24 exponential minus 6. And after that, let me simplify it more. Let me organize it more. V3 minus V2 minus 4 V1, something like X, Y, Z. Okay, and 6V equal VA minus V1. Now we want to calculate V1, V2, and V3. Honestly, I prefer this way because it's easier to us and will make us save many times, and we can solve it safely. Believe me, let me show you. Like the previous lectures, I told you I use this app. This app is the last version of this scientific calculator. At first, I will go to mode. After that, I will use the unknown elements equation. Will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, AX, BY, CZ equal B equal D sub N. Let me, yes. Now we have something like matrix. I don't know if you can see it or not. I will write all of these results here by using this way, this matrix. At first, I will write 3 equal. Here, when I push equal, that's mean I saved this number and I went it to another blank, another setup. Here, -1 equal 0 equal 168 equal 1 equal -1 equal -4 equal 24, and at last equal 0 equal 1 equal -1 equal 6 equal. I don't know if you can see it or not, because that I used another direction. Will be something like matrix, and I fold all of these blanks by using the same way. I wrote it this step here. The result will be x equals 6, x that's mean V1, 6 volt, y equal 12 volts, z equal V3, that's mean equal 16 volts. Now, by using the same way, let's solve the last question. Here, the circuit, the electric circuit, we have 3 different amount of resistance. Here we have 2 independent voltage source. Now, 13 volt, 20 volt. Here, the author wanted from us calculate V0 value. We will use a simple math trick. V0 node, I wrote it here and here and here. The both of them are right, because V0 can be started from here, can be started from here, or the same thing from here. Here we can write I1, I2, and we can say VS1, VS2, VS3, okay? And here I0 or I0, that's mean the current here I0. Let's start from Kirchhoff current law and Ohm's law. I1 on this side plus I2 equal minus I0, because at the different direction, plus I0 equals 0. From Ohm law will be like that, equal 0 to come benefit from VS and VS2. We will use this trick. V0. That's mean here V0 with the reference point equal 20 volts equal VS2, and here V0 to this resistance equal, let me show you, to come benefit from VS1 and VS2, we can write V0 minus V1, V0 minus V1, V1 here. That's mean V0 minus V1, not with the reference point. This I draw this point, I write it this point here to simplify and can benefit from VS1, V0 with V1 minus V1 equal VS1. V0 minus V1 equal 13 volts. V0 minus V2, I write it this note here. V0 minus V2 equal VS2 equal 20 volts. We have 3 unknowns and 3 equations. Let's work to modify equation 1. Here, equation 1, all of these equations, you can use the scientific calculator, like I said before, we must make the equation be without fractions, okay? Here, I write it, the equation 1 here again, V1 on 2, V2 on 5 plus V0 on 4 equals 0. Now let's try to delete these fractions. Will be like that. This equation 1. Equation 2, like I said, we must write x, y, z. That means x3, x2, x1, something like that. Because that I write it equation 2 like that, minus v1 plus v0, and minus v2 is 0, v0 equal 20. So equation number 3, by using the calculate, we will write the equation like that. And the results will be here, x1 equal 0, v1 minus 10, v0 equal 20 volt. The author wanted from us, calculate this point. If you couldn't understand how we can use this calculate, we can write some word key at the YouTube, and we will can see many videos and YouTubers try to explain how we can use it, but how we can use it to can calculate, to can modify, to can know the values of different 3 unknowns with 3 different equations. Thank you so much about your listening, your patience. Have a good day. And honestly, good night. Thank you, Mr.